The Earth's surface is made of rock. But you don't have to travel the world to study rocks. They're on your doorstep. Buildings are made of rocks which were once part of the Earth's crust. A town centre is an ideal place to start studying them.
Right. Hidden in the rocks are clues as to how they're formed. These are going to be some of the things that you're going to try and look out for as we walk around town.
Oh, look, a crystal. Fossils. Shells.
There's also sand grains. All we need now for our field trip is a sponge, some water, and some magnifying plates. Let's go and look at some rocks then.
Yeah.
Come on.
There are three types of rock to look out for. The most colourful can often be found on the front of banks. Architects use them because they're so attractive.
They're all different colours. Sparkly too. There's white and there's some black. Some grey as well.
This rock is made up of different coloured crystals, which is our first clue to what type of rock it is.
If you look, there aren't any gaps. They're all interlocking.
This is rock type number 1, igneous. The clues telling us it's an igneous rock are crystals and no gaps.
So in igneous rocks, each different coloured crystal is actually a mineral.
So what minerals are these?
This long pink one, they're a mineral called feldspar. And then the grey, glassy coloured minerals, they're quartz. But the very small, black, shiny minerals that you can see, they're called mica.
Rocks made up of these three minerals belong to a type of igneous rock called granite.
This bit's all smooth, like it's been polished. But this bit, it's all dull and rough. Like the rock would be in the ground.
Rocks look much duller when they're still in the Earth's crust. So how can you tell this is another igneous rock?
Now you've wiped it, you can actually see all the crystals.
They're quite hard to see.
Yeah, they're a lot smaller.
In years gone by, some cobbled streets were made out of igneous rocks, like granite. What does this tell you about these rocks? Igneous rocks are formed when molten rock cools and solidifies. The name comes from the Latin word ignis, meaning fire. Volcanoes happen at a weakness in the Earth's crust. It is very thin compared to the size of the whole Earth. Below it lies the mantle, an enormous layer of solid rock, which in some places gets hot enough to melt. A volcano erupts when this molten rock, or magma, is forced upwards and out. It forces its way to the surface through cracks in the crust and pours out as lava. The lava cools, and over time, a cone-shaped mound of newly formed rock builds up. The speed at which the lava cools determines which kind of igneous rock is formed. These two rocks both came out of the top of a volcano, but they're totally different.
It's really light. It's kind of like a sponge, but it's hard.
This one's all jagged. It's heavy. It's a nice colour. It looks like coal, but it's not coal.
Well, first of all, this one. It's really light, isn't it? This was actually spurted out the top of a volcano really quickly. I suppose it's a bit like a bottle of fizzy water, really. It's got loads of bubbles in it. If this was frozen, all those bubbles would stay in it and you'd see spaces. Just like the spaces in this. They're just loads of air pockets that have been frozen when this cooled. This is even light enough to float.
It's called pumice. It's too light to be used for building. Much better at getting that rough skin off your feet. On the other hand, this igneous rock, basalt, is much tougher.
This one's really, really heavy, isn't it? It's heavy because there aren't any holes in it. There aren't any gas bubbles. It was actually erupted quite slowly out the top of the volcano. This one won't float.
While basalt and pumice are two rocks formed from lava erupting out of a volcano, most igneous rocks are formed deep underground. This happens when the molten rock doesn't make it to the surface. It forces its way into existing rocks, cools down, and crystals begin to grow as it solidifies. This is how igneous rocks like granite are formed. So how does the rate of cooling affect the crystals? The magician is using a chemical called salol. When placed in a warm water bath, it changes from a solid to a liquid. Sandwiching a small amount between two sheets of cold glass, and you can see how quickly the liquid solidifies. It crystallises. But each of the crystals is quite small. If the glass is warm instead of cold, the salol cools down and crystallises much more slowly. The slower the cooling, the bigger the crystals. The crystals in this rock are quite small, especially compared to the crystals in this one.
So what type of rock is this then?
This is a rock.
Yeah.
Well, there's no obvious crystals, so it's not igneous.
There's no grains.
Or layers, so it's not sedimentary.
No, that's right. This is our last type of rock. It's a metamorphic rock.
Metamorphic means changed, so a metamorphic rock would have started life as either an igneous or a sedimentary rock. They're the most difficult to spot. The only obvious examples in town are coffee tables, roof slates, and statues.
It's got a sugary feel to it. It's a nice colour. There's no crystals or fossils in it.
This rock's called a marble. It used to be a limestone, but it's been subjected to a lot of pressure and temperature. It's just like baking it in an oven.
A process which happens deep underground. The heat might come from a volcano. As magma pushes its way through the Earth's crust, the surrounding rocks get hotter. Sometimes they'll get hot enough to change. But you can't see it happening. The rocks are far too deep underground. As well as being baked, rocks can be squeezed. Pressure builds up in the Earth's crust. Eventually, it can cause rocks to change. So, the Earth's crust is made up of three major rock types: igneous, sedimentary, and metamorphic. But they're changing all the time, albeit over hundreds and thousands of years. They change from one rock type to another.
Let's start with your earliest memories.
I remember a baking hot volcano. Then things cooled off and I began to feel more solid.
Sounds like an igneous condition.
Then I started to fall apart. I was swept along at top speed in a river and was at the bottom of the sea before I managed to pull myself together again.
Right. A sedimentary phase.
I must have rested there thousands of years, maybe. Everything was getting on top of me. Then the pressure just became too great.
Oh dear.
I felt like I was changing again, getting stronger and stronger.
As I thought, metamorphic days.
So, Doctor, will all this changing ever stop?
I'm afraid it won't, Mr. Rock.
Oh.
It's perfectly natural.
The fact is that rocks are changing all the time. They're part of a never-ending cycle. They're even changing right now.